Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will have a continuation of episodes of water flood playlist. And today's topic is about water encroachment problems. So if you're conducting water flood right now, if you're modeling water flood or water injection operation right now, this topic will be very important for you. Okay, but it will be brief. This video will be brief. So I'm just going to to talk about some of the potential problems regarding water encroachment issue that can occur during water flood or water injection operation. Okay, so let's go ahead. All right. So the first thing is viscous fingering due to poor mobility ratio. So if you have, let's say, an injector there at the center of your reservoir section, and you have producers there, and unfortunately you have poor mobility ratio. Please remember that mobility ratio is the mobility of the displacing fluid, in this case is water, divided by the mobility of the displaced fluid, in this case is oil. Okay, so if you have mobility ratio greater than 1, it means that your water will move faster than your oil, all right? And your water, when you inject, your water will just go there directly fast to the producer. And this phenomena, we call this viscous fingering. All right. So after you inject water, the flow of the water will be like fingers, and it is driven by viscous force. Okay. So you remember in viscous force, one of the important parameter should be viscosity, and viscosity later on will be mobility ratio. Mobility, I mean. So mobility is, of course, permeability divided by viscosity. So it's mainly driven by the viscous force, viscous phenomena. So first thing, viscous fingering. By the way, some literature say that viscous fingering occurs mainly in microscopic scale, okay, rather than macroscopic scale. But I I I don't think that's quite right. Okay. Of course, viscous fingering can occur microscopically and macroscopically. But if you're talking about macroscopically, of course, it will not be viscous fingering alone. There will be other factors influencing the fingering shape of the water. Okay, so that's it. This is the first thing. This is the first problem that we can have, that we need to face. It's viscous fingering due to a poor mobility ratio. Okay. By the way, if you want to check or if you want to read about this, you can go to this website. Okay, I take the picture from this website. Thank you for this website. The picture is really, really good. And the second problem, unfortunately, we can face in the field is horizontal directional high permeability trend. So if somehow you have high permeability trend in that direction, okay, then of course, if you inject water here, water will move faster across this direction. Okay, this can occur, for example, if you have, this is the direction of the maximum horizontal stress. So fracture will be propagated following this direction. Okay, so in many cases, this direction where the hypermobility trend is developed is because of this, the direction of the maximum horizontal stress. But not always, in many cases as well, this is just due to depositional issue. Okay, so originally the deposition is developed like that. Somehow permeability trend is greater in, let's say, in a particular direction, whether it is like this or it's like this or it's like this, okay, driven by the position. But again, it can also due to the maximum horizontal stress direction. Okay, so that's it. If you, for example, if you have high permeability trend like this direction, then you need to arrange the position of your injectors in such a way that it will avoid the fast water breakthrough. Like in this case, the position of this injector is not very good. It will be much more effective if you set your injector there, if you drill your injector there. Okay, so that's the second problem, horizontal directional high permeability trend. And the third thing is actually matrix channeling with crossflow plus viscous fingering. Okay, so matrix channeling means water will be channeled from the injector to the producer because of matrix permeability. So like in this case, this layer will have matrix permeability, let's say K1, and this is K2. And in this case, of course, K1 is greater than K2. And then the problem is worse because we have viscous fingering as well. Okay, this is a combined problem of permeability contrast and mobility ratio contrast. And you may or may not have permeability barrier between the two layers. In this case, there is no good barrier, okay, no good barrier such that you have developed crossflow. Okay, so it's like that. In this case, permeability in the first layer, in the upper layer is greater. So the first layer will be depleted earlier, and the water on or the fluid from the second layer will be directed to the depleted layer, which is to the first layer. Okay, so water in this case will flow from layer 2 to layer 1 because of depletion occurring in the layer 1. Okay, and of course the viscous fingering also makes the problem worse. Okay, so this is the third thing, matrix channeling with crossflow, viscous fingering. Okay, it should be fingering, by the way. By the way, all these cases are not just concept, are not just idea, they really occur in the actual water flood or water injection operation. Okay, and the fourth thing is actually matrix channeling without crossflow. So again, we have channeling because of matrix permeability. In this case, again, K1 is greater than K2, such that the first layer will be depleted first because you drain more from the first layer. Okay, and yeah, water will move faster in the first layer because of depletion and because of course, the permeability itself. Okay, and in this case, you have a good barrier separating the first layer from the second layer. So it's barrier, mainly it's shield. Okay, so there is no cross flow from layer 1 to layer 2 or vice versa. Okay, and because the second layer has low permeability, somehow the water will move slower towards towards the producer. Okay, and the fifth is actually matrix water coning. For example, if you have bottom water there or aquifer, bottom aquifer, and if you produce at high flow rate, okay, in such a way that, yeah, there will be balance first between the gravity force versus viscous force, okay? And in this case, if you drain too high, If your flow rate is too high, water will move against the gravity. So the gravity will go down, of course, because it's gravity, but water will go against the gravity because of the viscous force, because of the high drawdown, because of the high flow rate, such that water will move to the upper side and creating a cone shape towards the wellbore. Okay, so it can occur if you have high flow rate, high drawdown, okay, high flow rate and high drawdown, and sufficient permeability anisotropy. Of course, in order for the coning to be developed, you still need vertical permeability. Okay, so if you want to solve water coning issue, it is recommended that you produce your well at a lower rate, lower than the critical coning rate. But in many cases, this rate is not economical. So again, it will be trade-off. You want to have a good economics, but you still want to maintain your water cut, to maintain the life of your well or your field. So at the end of the day, it is, you need to consider the technical things, maybe from simulation, and the economics. Okay, so these are the problems that we have: first, second, third, fourth, and fifth. And the next one is fracture channeling. Okay, it is very clear. Just by the name of it, you can understand already. It's channeling, but channeling not occurs mainly because of the matrix permeability, but because of fracture. And generally, or in most cases, or in all cases, permeability of fracture will be high. So water will move faster across the fracture compared to across the matrix. So if somehow, unfortunately, you have fractures connecting your injector and producer, okay, this is the producer and this is the injector. If unfortunately you have fractures connecting your injector and producer, then of course water injected from the injector will go fast directly to the producer, and that's not good. And this fracture can be natural fractures, can be hydraulic fractures, or can be water flood induced fracture. So you need to be careful, okay? And fortunately, you can assess the existence of fractures using observations through well testing, through the log, and through, you know, core analysis, or maybe just analytical approach by comparing the production rate and injection rate, something like that. You can infer whether there is, fractures connecting your injector and producer or not. Okay, so that's it, fracture channeling. And the next one is solution or Vugular channel. So it's a bad thing. Somehow you will have bugs, okay, or it's like cave. It's a very, very, very high permeability zone, very, very high permeability layer. It can be thick, but it can be also thin. But the main thing is actually high, high, high permeability. Can be developed or can be existing since the beginning between your producer and injector. And of course, if you inject water from your injector and somehow unfortunately it is connected to the VUX, and VUX is unfortunately connected to your producer, then it will be just a very, very, very high conductive channel that make your water will just go directly to the producer, and it just recycling water. Okay, recycling water. That's not good. I hope you don't have VUX in your reservoir, because it can be the main thief zone. Okay, thief zone. It steal your water. Okay, it just snatch your water, take your water, and just bring it to other places like your produce or something like that. So it's a very, very, very high permeability zone or streak or layer. Okay, so solution or Vugular channels. And yep, channeling behind pipe. Okay, so channeling, when we are talking about channeling behind pipe, first we have water zone there, and we have bed cement. Okay, bed cement. Sorry for my writing. So the water will go through the leaks of the cement, through the micro channel, across the cement, and it will flow towards your perforation. It will flow towards your completion. Okay, the flow from the water zone across the microanalysis throughout the cement sheet, cement layer, and it will flow to your perforation. Okay, so it's channeling, but the channeling occurs behind the pipe, or in other words, behind the pipe means at your cement sheet or cement layer. Okay, across microanalysis, microchannel in the cement layer towards your perforation. And lastly is, this is the bad news, your casing is just leaking. Okay, your casing is leaking, and of course it will be very, very easy for the water to go towards your leakage, the holes on your casing. Okay, so that's it. We have how many problems? 1, 2, 3, 4, 5, 6, 7, 8, 9, if I'm not mistaken. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have 9 problems, and there are still many other problems actually occurring on the field, but I think we can call it a day. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching, and see you again on the next water flood videos. Thank you.